Welcome to a video that discusses strategies for linear equations on the SAT math section. So let's talk about the basics of solving linear equations. Well, a linear equation will typically take on this form, y equals mx plus b, where m is going to be your slope and b will be your y-intercept. Slope, hopefully you remember, is rise over run, or essentially just change in y over change in x. So the vertical change over the horizontal change. So change vertical coordinates, change over change of horizontal coordinates. Um, we really want to spend some time talking about modeling real-world scenarios that involve linear equations, and so how you can take the information in a word problem and extract the slope from that, and do likewise with the y-intercept. Hence, create an equation and answer whatever question you need to about the real-world scenario. We will work with linear graphs. We'll do some examples, and again, slope is change in y over change in x, rise over run, as we know. Some other things that are good to know is that positive slopes run uphill. That's a positive slope. Negative slopes run downhill. It's a negative slope. Horizontal lines have no slope because there's no change in y. Vertical lines are undefined because there's no change in x, and hence you divide by 0. Parallel lines always have the same slope. They rise and run the same way. Perpendicular lines have negative reciprocal slopes. Examples of 3 and negative 1/3. So let's start with an example here. And we're going to do an easy, medium, and hard, and then a combination of multiple choice, free response, and calculator, no calculator, because that is how the SAT math section works. So Darren needs to buy several white dress shirts for his new job. He finds one he likes for 35 bucks that's on sale for 40% off. He also likes a blue tie that costs $21. Which of the following represents the total cost, not including tax, if Darren buys X of the white shirts on sale and 2 of the blue ties? Well, if he's buying 2 blue ties, we know it's 42 bucks, guaranteed. And then the white shirts, we don't know how many white shirts he's exactly buying. But if he's buying X white shirts, what you want to realize is that Y is going to be the total cost. So Y equals mx plus b. There's the total cost. And if you don't buy any white shirts, you're at least paying $42 for the blue ties. So B, coincidence that blue ties B and B a y-intercept. But anyway, if you don't buy any white shirts, if X is 0, you're definitely going to spend at least 42 bucks for the 2 blue ties. So M, in this instance, is going to be the cost for a white shirt. And that's how we extract the slope from the word problem. We realize that, well, it's not going to be $35, by the way. That will be, I think, 21. You should use a calculator, by the way. Calculator is allowed. But I believe that will be 21. So it's $21 per shirt. And think about it, that is going to be a ratio, right? You're looking at change in money per change in shirt. So for every $21, that is a change in the cost of what you spend, you increase by 1 white shirt. So that's going to be 21x. And that's what the answer C. So your total cost is 21x plus 42. Let's look at another problem that's somewhat cut from the same cloth. Again, no pun intended. A car rental agency charges a per day rental fee, which includes a daily mileage allowance plus a certain amount per mile driven over the allowance. The graph above compares the miles driven over the allowance and the total cost for a 3-day rental. What does a c-intercept represent? So again, y equals mx plus b, and x is going to be the miles you drive. So if you don't drive any miles, right, you're going to have to at least pay the per day rental fee for 3 days. And that's going to be your y-intercept. the rental fee for 3 days. X is going to be your miles driven over the allowance. And your y-intercept, whether that's change in y or change in x, basically it's going to be the cost you spend per mile driven over the allowance. But they just want to know what the c-intercept, or basically the y-intercept, represents. And that's going to be what you pay in rental. So the total cost of a 3-day rental, assuming the car is not driven over the allowance. And so that's roughly about $64. So that's why it's D. Lastly, let's look at 20. Now, if you have infinitely many solutions, and here we have one equation, you can think this is like y2, and this is y1. And when you're looking at two linear equations, I mean, you could write this as two linear equations if you wanted to. When they intersect just once, of course, you have one solution, right? If they don't intersect, of course, you have no solution. In this case, they're parallel with the same slope. And if you happen to have two lines that are the same thing, you have this, and then you have another line on top of it, it's of course the same slope and y-intercept. So, and they're the same line. And that would be infinitely many solutions if that happens, because it means there's lots of answers that are common to both equations, because they happen to be the same. And that's what we want to do here. We want these to be the same expressions on each side. So if you were to separate them as two different equations, they would actually be the same equation. So y1, when you clean that up, is 3x minus 2 minus 3 plus x. So you get 4x plus 5. And y2, of course, would be, you could probably factor on an x, so it would be 1 plus a plus b. So we see that the slope here have to be same on each side if you want infinitely many solutions. And the y-intercepts have to be the same also. So your b is negative 5. And your a is going to have to be 3, because 1 plus a equals 4. A would have to be 3. So when you want a minus b, 3 minus negative 5, you get 8. So this will at least introduce you to the way linear equations are handled on the SAT. And then when we meet again, we will do some practice problems. And of course, there'll be some problems we'll ask for you to do on homework as well. Okay, goodbye.